Okay, we're going to do a distance problem here that's going to use quite a bit of the map. So coming up with different strategies for long distance stuff, I'm going to need two of these things to help me out. So let's read off the problem so you understand what's going on here. So this is the problem that we're going to solve here. And it says, at 10 o'clock you're located at the black and white mid-channel marker WH off of Westport Harbor, approximately 7 miles east of the Seconic River. So here on the map, this is the Seconic River. If we're going 7 miles east, that's where our WH buoy is located, right there. Okay, now we're going from there and we're going to plot a DR course to Bell Buoy 1 at the harbor on Block Island. Okay, so down here in the lower left corner is where Block Island is located, and there's a black Bell Buoy number 1 that's located right here. So just to figure out magnetic course and distance for now, and that's going to be our dead reckoning. So we're going to go from here to here, okay? So, oh no, not even to here. So the error that you make is going to be significant if you don't get this really pretty precise. So this is one technique that I'm using to help myself out, is I basically look at the points and try to line it up so that way I can slide this to the other point, okay? And if I can slide this across where I have this set up well, like this, then that means I've probably got a pretty straight line going for my dead reckoning. So what I'm gonna do is, I'm gonna do this a few times because it's gonna take a bit. So here's my bell buoy, and I wanna be able to slide this up to the marker that is at that WH. Okay, just a little bit. Let's see, what about there? Okay, let's see if that'll slide down. Nope. Right there. Right there, nope. Let's try this. No, a little bit more. A little bit more. Okay, that's pretty good. Ooh, almost have it. Let's see here. What about there? No, still a little bit off. Let's see. Let's just go a little bit. Okay, so a little bit like that. Okay, so that's pretty good. That's better. Okay, let's see if we slide that up. No, we got to go a little bit more to the right, like 1 degree. But you can see that over long distances, how just a tiny change can make all the difference in the accuracy of your compass heading. Ooh, that is pretty close. That's pretty close. All right, I don't know if I want to push it, but I will just to see if I can get it. I would rather get this down so that it's really accurate versus doing the whole problem like with error compounding all the way through my problem. Oh, shoot, let's see here. Just a little bit. Let me see if I can bump this over. There we go. Well, that was a good technique. Let's see here. Okay. Now, a little bit more this way. Actually, I should put the parallels probably a little bit more midway between these two. Maybe that'll make my adjustments easier. Let's see. Okay, sometimes you got to do some experimenting on the fly here. Ooh, that's really dangerously close. Okay, so we have that. If I can just turn this slightly this way, right about there. That might just about do it. Okay. So close. Let's see here. All right, what about that? Oops. Felt that move. Let's see here. Okay, that might be it. Let's see. Yeah, that might be as close as we can get to perfection. Okay, so now what to do? All right, so what I would do is don't lose this. Don't worry about your parallels for a second, but do draw a line that goes along here. Now, bring the parallels against that, press it down, hold, and then extend this up and hold again. Let's see if we can continue this line all the way up. Whew, just made it. Okay. Okay. So there it is. That's our straight line going from here to here. Okay. So that took a little bit, but hopefully that'll pay us back in some dividends of accuracy. Okay, so they want probably magnetic course and distance, right? Okay, fair enough. So for this, I'm going to take a seat. I don't need this, hopefully, for a little while. And now what I'm going to do is I'm going to span out my dividers. I'm going to follow along the line that we just drew, and then we're going to bring the parallels right up on that line. So here's our line. I'm going to slide my parallels right up on it. There we go. I'm going to hold. And now I'm going to hold the other side. And I'm going to swing. Swing, bada, 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 swing. Okay. Now the thing is, we're going from here to there. So it's important that you get the direction right and make sure that you mark it correctly. So let's see here. That one is actually a little bit, let's pull this a little bit. There we go. All right, now let's get the pencil there. Okay, that's better. So that is going to be our magnetic compass heading. So let's see. This is 240, and it looks like our heading's going to be close to 244 magnetic. All right. So I'm going to double check that since the distance is so long. Let's double check it just to be on the safe side. So here is our angle. I'll put this right up against here and hold, lift, and swing, press, hold, lift, and whoops, swing. I actually didn't need to swing it that much. Okay, so I'm holding this down and pretty much the same thing. But you know what? Sometimes when you draw that line too thick, it's going to obscure the other parts of the compass rose, which is not cool. So I'm going to do this one more time for good luck, and hopefully this will be it. Okay, but 244 is kind of what we're looking at there. All right, and we're going, let's see here. So I'm going to go, actually I'm going to close this so that I can swing it out. Okay, so I'm on the line. Whoops, that one moved just a tiny bit. Let's go right on the line there. Okay, you can see maybe from that angle is probably a little better. I'm putting those right up on the line, holding my parallels up against the dividers like so. Press and hold, move them out of the way, and now we're going to swing to the center of the compass rose, and there it is. And okay, on this one I got 245 degrees. So 244, 245. We'll find out which one is right, but I'm going to go with 245. So course 245 magnetic. Okay, now here comes the fun part where we figure out the distance. So this is quite a long distance. Now, as far as like spanning and walking goes, I can span it to 5 and just do increments of 5. It's kind of easy to keep track. The distance is also a bit long, so actually I'm going to span this out to 7, just so I don't have to keep twisting and turning my dividers. Okay, so I'm always using the latitude lines on the side here to indicate distance. So I'm going to very precisely drill in the point at the intersection on my latitude lines right about there. Well, it's not exactly right. There. Okay, well, so you can get kind of obsessive about this because you really want to do this right. Okay, I'm going to just call that. That's good. Okay, so right there, and we're going to span it out to about 7. So let's bring this back a touch. And okay, so that's 7 nautical miles. 1, 2, 3, 4, 5, 6, 7 nautical miles. Okay, so I'm going to walk this over to measure the distance. So here we are at 1. Okay, so that's going to be our starting point. So that's 7. That's 14. That's 21. Wow. 21. 28. Okay, so there's 28. Now I gotta reduce this. So 28 nautical miles, 28 nautical miles, 28 nautical miles, 28 nautical miles, and let's see, 28 nautical miles, and whatever this is. So 28 nautical miles plus this. Okay, so according to this, it's 28, 28 and a half is here. So 28.65. 28.65. Now, that's what I'm going to use. So if I made any mistakes here, that's going to carry throughout the rest of the problem. So I'll just deal with it, I guess. Okay, so here it says your boat speed is 6 knots. Plot your hourly dead reckoning positions. Okay, so when your boat speed's 6 knots, this is actually quite easy to do, because what you can do is you can just span out to 6. So let's see here. Let's get this precisely drilled in. Okay, right about there. And let's span this out to 6. Right about there. Okay, so this distance right here is 6. 1, 2, 3, 4, 5, 6 nautical miles. You're going 6 knots, so that's 6 nautical miles per hour. Okay, so we're going to start our dead reckoning from back here, and I'm going to mark everywhere this meets up. All right, it's a bit awkward with the handing here, so I'm going to just drill into my map a little bit to make that more secure. And the divider touches down right about here. So that's my first hour, okay? So I'm going to put a semicircle and a dot, okay? Now, did they tell me what time I start? Yeah, I start at 10, so I'm going to just write 10 o'clock here. And then here is my 11 o'clock dead reckoning spot. Of course, there's probably going to be some set and drift that's going to mess me up along the way, but that's the whole point of these problems. Okay, so I'm going to drill in, even though maybe I shouldn't, damage my map a little bit, but it's for the benefit of society and my dead reckoning. Okay, so there is my next point. Kind of push the compass out of the way with the pencil, and that's my 12 o'clock dead reckoning. I'm going to go here. Okay, I'm going to drill this in and put this here. And oh, that was quite a slide. Matter of fact, when that happens, kind of a good idea to double check to make sure you still got your 6 nautical miles, which I do. Thank goodness. Okay, so let's drill that back in. There we are. Lay this down gently. And we're going to push this out of the way. That did not work out the way I thought. Let's try that again. Okay, here, here, and there. Okay. So, right about there is going to be my 1300 hours. And let's see. So this is good. You can kind of, if you're doing if this were a real trip, you could actually check your position on the hour to make sure that you are moving correctly. Okay, so here is 1400 hours. Whoa, take it easy out there. I'm trying to navigate here, Fido. Okay, so here is 1400 hours. Okay, so 10, 11, 12, 13, 14, and then 15 is going to go a little bit longer, so that's going to be that. Okay, now probably comes the fun part. So everything's going swimmingly, right? Everything's going great. You're on your trip. But at 11:40, you observe a radio tower and a spire that line up to form a range. At the same time, you take these magnetic bearings. So what's a range? A range is basically 2 points on a map that line up, and you could use those to give you an estimated position. So based on that, WADK, let's see, is a radio tower and a spire on Aquidneck Island. Okay, so Aquidneck Island. Okay, so here's Aquidneck Island, here's the spire, and here is the radio transmitter. So these 2 points here, they're really tiny. So I'm going to use my dividers to see if I can get a little bit more accuracy as I line this up. This is going to be quite a trick. But if I hold this down, let's see, I actually need to span this out just a wee bit. Okay, that's a little better. Oof, hard to get it. Hard to get it because it's so, you know, these points are really close together. So the compass, the dividers don't necessarily help you like they did so much with the other problems. Well, maybe this is one of those times where we just have to eyeball it. So I'm going to look here and just try my best to draw a line through those 2 points. There's 2 points on there that I can see. Okay, and so that's my range. Hopefully it doesn't go much further than that. Okay, but that's what a range does. So it allows you to kind of like see what's going on there. Now, that's one line of position, but we've got Buzzard's Light at 94 degrees. Okay, so Buzzard's Light is actually way over here, and so that's where Buzzard's light is. So let's see here. We've got to figure out 94 degrees. Okay, let's see if we can do this. So here's 94 degrees. There's 95. Right there. Okay, and then here's 94. Is right there. Okay, so that's 94 degrees. Okay. So I'm going to put this here. Right up against it. Hold. Okay, let's get this out of the way. We got to get to Buzzards, so slide this over to Buzzards and hold this down. Okay, here's Buzzards. Okay, so thank goodness I drew this long enough. And here's Buzzards, so I drew this line from Buzzards, and so right now this is what our estimated position looks like. But we got one more point, which is the spire at Little Compton. So here's the Little Compton spire. So that's at 22 degrees. So let's find 22 degrees on the map. And there's 22 degrees right there. Okay, whoops, moved it. Try again. So 22 degrees is right there. And let's see here. Close these up. Let's just double check. Okay. So let's hold this against. Whoops, I moved it. 22, 22, 22. Okay. So spire at Little Compton. Walk over here. Okay, so here's our spire at Little Compton. I draw a line here. Okay, let's see where we're at now. Okay, so here's our little triangle. It's super tiny, but this is the best I can do here. Okay, so our triangle, all right, there's a little triangle here where the three lines meet. And so this is our estimated position, right, or from our lines of position, and this was done at 1140. Okay, so this is 1140. Now, theoretically at 1140, we should have been somewhere over here, but we're not. We're over here. So that means that the currents pushed us this way. So we've got some kind of current acting on us that's pushing us in that direction. So how do we figure out what's going on? Okay, so from this point, we have to figure out to 11 o'clock, I believe, so we have to see. So all along, what actually our track was actually going from here to here. This is what we were actually doing. The boat was moving from our starting point, going along this line to this point right here. Okay, and just to kind of reduce some confusion here, I'm gonna just get rid of some of this extra pencil mark, just because we did our ranges. So okay, you don't have to do this, but anything that'll help you reduce confusion. Maybe this is just a personal pet peeve of mine. Okay, so we were actually going in this direction, and we wanted to go this way, but that wasn't happening. So what we should do is we should figure out where we should have been at 1140, all right? Now, the math works out really sweetly because we're going at 6 knots, right? And 1140, if you think about it, 40 over 60 is going to be 2/3. So we're kind of 2/3 of the way over. And if we're going at 6 knots, then that means that we should be 4 nautical miles along the way, right? So at 2 nautical miles it'd be 20 minutes, 4 nautical miles at 40 minutes, 6 nautical miles in 60 minutes. All right, so let's figure that out. So let's take our dividers, put that here. Okay, so that's 1, 2, 3, whoops, we need to go one more. Okay, there we go. So 1, 2, 3, 4. Okay, so that's 4. Okay, so that means we should have been right here. Okay, should have been here. That's where we should have been at 11:40, right? Okay, so I'm going to draw a line from where, let's see. So we can backtrack to 11 o'clock. If I line these up just so, let's get the dividers again. And I want to put the divider there and put divider here. Okay, so I'm basically connecting the 11:40 time. I'm putting my dividers up against it for accuracy. And now I'm going to walk these over to the 11 o'clock hour. Okay, so here's my 11 o'clock hour. So press and hold, walk, press and hold, walk, press and hold. Okay. So this is what happened at 11 o'clock. Let's see. Get it right there. I guess that's pretty good. Okay. So at 11 o'clock, all right, so this is where we actually were at 11 o'clock. Okay? This was our dead reckoning, but this is where we actually were. So in 1 hour, this is our actual distance traveled. We were going at 6 knots. Okay, that was our intended, but then this 6 knots got pushed a little bit backwards here. So our actual speed is going to be this point. So we can look at this as distance, right? We can look at this as distance, 6 knots, right? 6 nautical miles rather. We can look at this as a distance, but we can also look at this from the perspective of direction, right? We're moving in this way at a velocity of 6 knots. So we can also look at these as vectors. We're moving in this direction, but the current is actually pushing us in this direction. So we can measure all of these things, right? So we know this is 6. This is 6 knots because that was our boat speed. And we can take a look and now measure how much the current has put us off course, and we can measure what the current speed is. Okay, so here you can see I put my dividers between the two 11 o'clock positions. Okay, and then using this I can figure out how fast the current's moving. So it looks like it's moving at 1.4 knots. Okay, so 1.4. Okay, so we're being set in this direction by 1.4 knots. Okay? Now, what is the direction of this, right? So, all right, we can figure that out too. Okay, let's just connect the dots again. We're going to connect these two, 11 o'clock to 11 o'clock. Whoops. Back this up a little. And then we're going to put our dividers here for accuracy. Whoops, I moved it. Actually, let me just drill in a little bit. There we go. Okay, so from here, we're going to walk. We're going to walk, we're going to walk, press hold, walk, and we're going to press and hold. Okay, so now, looking at this, we're being set in that direction, okay? Now it looks like it's a little bit off in the center, so I'm going to just estimate that one more time. But it basically looks like we're being set by 120 121 degrees. All right, so I'm going to double check that just to be sure. And these kind of problems, you know, you wonder why the exam for the navigation course is so long, but you know, you now understand that if you're being careful, okay, sometimes, you know, you need to double check some things to make sure that you're okay. All right, so walk and hold. Okay, lift and hold. Lift and hold. And now I'm gonna come right up against the crosshairs there. Okay, so that should be good. Here we go from here. Okay, I feel like this was more accurate. So this was 120 degrees, right on the money. This was 121, 122. So let's see how well we did. So let's see. Well, I got a little bit ahead of myself, but the set was, I'm saying it's 120 magnetic, and I said that the drift was 1.4 knots. Okay, I've solved these problems before, can you tell? Okay, here's where they say how many miles are you from Buzzard's Light. So I skipped that part because I got so into the set and the drift part. And the thing is, they want to know, this is our estimated line of position from before. Oh no, sorry, this one. This is our estimated position. They're saying how many miles are you from Buzzard's Light. So Buzzard's Lighthouse is actually over here. So we can estimate that by drilling in to this point. And then I'm going to span this out to Buzzard's Light and get that information. I guess they want you to do this as a check, so that way if you check your answers here and you realize that you're way off, then you can simply try it again, try to figure out your position until you get a more accurate fix. Okay? But now I've got the distance here, so let's estimate how far that is. So let's go here. Whoop, 15. Okay. So this is 567.2. Okay, so how did I get that so quick? So 5 is from here to here. 15 to 20 minutes is 5 minutes or 5 nautical miles. 6 nautical miles. 7 nautical miles, 0.2. So I'm going to say this is 7.2 nautical miles. Okay? All right, part D. From your 1140 fixed position, which was here, they want you to plot a new dead reckoning course to get to the harbor. So in other words, now that you realize that you're set a little bit this way, then you have to make sure that you plot a new course to the harbor, right? Okay, well, we got to start all over again, believe it or not, pretty much. We have to kind of draw another dead reckoning line because this dead reckoning line is almost useless to us now that we know that we have been set apart from the current, you know, or by the current. So I'm going to do the slidey thing again and see if I can slide up. Nope. Let's get there. Let's try that. It's pretty close. Let's push. There we go. All right, so right there. Nope. All right, let's try pushing up a little bit on this side. Okay. Ooh, so close it hurts. All right, let's bring this down like a degree. Okay. All right, let's see if that looks good there on that side. And oh, just so ever so little. Okay, let's try that. Maybe that. Okay. Yeah. That's gonna do it. Okay. So I'm gonna draw my line. This is my new dead reckoning line, by the way. New and improved. And there we go. Okay. So this is my new dead reckoning line. Now, I've got some information I didn't have before. I've got my current. So what I have to do is since I know that the current is at 120 degrees magnetic, I got to factor that in. So let's do that. Let's put our compass rose here. Let's go to 120 magnetic. Okay, so here's, whoops, moved it again. All right, let's get that out of the way. And where are we going here? All right, we're going here. Okay, so put this up against, hold, and swing. Whoops, I swung that sucker really far. Okay, so let's see here. Let's bring this like so. All right, swing this out. Okay. I guess the mailman's here. Okay. So this is 1.4 knots. So let me bring this back. Okay, here is 1.4. Okay, I'm gonna do the same thing here. Okay, so this is what's going on here. Okay, so this is the current effects right here I'm doing. Okay, so this right here, this length is the same length as here to here, okay, because this is the set from, this is the drift. This is the drift. Set is direction, drift is distance. So this is the same distance from here to here, but we know that our boat is going 6 knots, right? So now I gotta span this out to 6 knots. So, okay, so let's span it out to 6. So there we go, we're in the pocket, span this out. Okay, so I don't want my hand to cover the video here, but check it out. We'll go to 6, which is right about there. Okay, so that's 6 nautical miles, or 6 knots in this case. 1, 2, 3, 4, 5, 6. Golden. Coming back. Here we go. So let's go from this point. Now we got to rejoin, right? We got to move in a way that rejoins us back to our dead reckoning line. So here is our dead reckoning line, like so. And I'm gonna push this out of the way. Okay, and so there it is. So let's do a double check. Okay, here is our dot, and here is that mark. Okay, that's pretty cool. So our course has actually got to follow from here to here. This is the direction we actually have to steer because the current is constantly pushing us around. So we don't want to get pushed too far off our course. So, okay, so this line represents 6 knots at boat speed. This represents the set in the drift, and this is our dead reckoning, okay? So we're actually going to have to steer, in order to keep meeting up at these points on our dead reckoning, we need to steer the boat in this direction. So now that we've got that, what we can do is we can figure out what's that angle, okay? What's that angle that we need to steer if we're going to do this right? So, all right, so I'm going to put that there. I'm going to put my dividers up against it, press down, and hold and swing ever so gently, right about there. Go through the center. Whoops, is that a little high? Yeah, that is a little high. All right, let's bring it down a little. Okay, right about there. Yeah. Okay, so in order to keep on our dead reckoning, we've got to hit here, which is 250, 260 exactly. So from here, we did plot a new course, okay? And I probably solved a bunch of these things already, right? Because here they want to do the set and the drift and do all that stuff. So anyway, I got a little bit excited and ahead of myself here. So the magnetic heading to stay on course is going to be 260 degrees magnetic. We'll worry about the rest later. Let's figure out the other stuff that they wanted here. So it says from our fixed position, plot a new dead reckoning course. So we did that. And then they want to know what is the magnetic course and distance. Okay, well, that's pretty easy. Okay, hopefully you're seeing that the procedures that you follow are getting repetitive. So we just put our dividers along this line, like so. Put this up against the dividers, ever so gently. Press and hold, and swing, and right about there. Okay, so this looks like 249. So our dead reckoning course is on a heading of 249 magnetic. The distance, and again, I like to count by fives when possible, just because it makes the math convenient. Using my latitude lines, there's 5. So where are we starting here? Okay, here's our estimated position. Okay, there's 5. Swing. Here's 5 more. Swing. It's 10. 15. And 15. Almost 20, not quite. So a little bit less than 15. So, sorry, a little less than 20. So this is 19, wow, 19 nautical miles. Okay, so distance was 19 nautical miles. The drift was 1.4 knots. Just want to make sure I got my units right. Okay, so we did that. We found our this was our dead reckoning course. That's what this was about. So that's our new dead reckoning course starting at 1140. And it's 19 miles to go, 19 nautical miles to go. Now to stay on the course, we gotta hit 260. Now it says, what's the true speed of the boat? Okay, well, that's actually quite easy to figure out because you just have to look at the right vector, okay? Here is our current right here. So this is our set and drift. The distance is the drift. And then we've got 6 nautical miles from here to here. But our true boat speed is going to be from our estimated position to where this line meets up on the dead reckoning, okay? This is like in order to steer and maintain that dead reckoning course. So I'm going to span this out, and this distance right here, that's the true speed of the boat. So you've got the speed of the boat, you've got the set and the drift from the current, but this is the actual speed of your boat right here. So let's figure out what that is. So that's 5, right on the money. Wow, that's frightening. Okay, 5 knots of boat speed, and your estimated time, right? Well, here you know the distance. That's what the dead reckoning is good for right here. So you know it's 19 nautical miles, okay? So 19 nautical miles, and you know your true boat speed, right? So you're actually doing 5 knots of boat speed. So it's almost gonna be 4 hours. So let's get the calculator and find out. So, all right, this is it. This is the final stretch. 19 divided by 5 equals 3.8. So 3.8 hours is what it's gonna take. Now be careful because they asked you for ETA. Remember that all this magic was happening at 1140, okay? So we're gonna need to add whatever hours are to 1140. I don't know why I did that. There we go, that looks more normal. Okay, so whatever we figure out from here. So let's figure out what 0.8 of an hour is. Okay, so 3 hours and 48 minutes gets tacked on to 1140. So 8,841. Okay, so this makes no sense. So let's subtract 60 minutes, right? And so that means we'll have an extra hour, and then we'll have 28 minutes. So this is my estimated time of arrival. And now comes the fun part. Let's see how accurate we were. Okay, from the top, here we go. So, problem number 3, they said, let's see, this is practice problem 4. Oh no, this is 5. Okay. Okay, so here we go. So, course problem 3, magnetic. Okay, they said 244, I said 245. Now remember, this is the big one, right? Because if this is off, then the rest of the calculations are going to be slightly off. So hold on to your hats. I estimated the distance at 2865. They said it's 28.4 nautical miles. Hopefully not too big a difference there. Okay, I got 7.2 nautical miles was our estimated position located from Buzzard's Light. They said it was 7.3 nautical miles. That's acceptable error right there. The set from the current was 120 magnetic. I said it was 120 magnetic. The drift was 1.4. They said 1.25. Ooh, that might hurt me a little bit in my estimations. Let's see. From the fix to get to Harbor Buoy 1, I said it was 249 magnetic. They said it was 250 on the money. Distance of 19.7. Oh, wait a minute. Didn't I say that it was also 19.7? But maybe I didn't write it down. Oh, shoot. Oh, boy. This may be where I get points off. So, let's see here. Oh, what a tragedy that would be. Okay, so here's 5. Here's 5. Okay, so 5. So this is the distance from here to there. Oh, goodness. All right, let's see here. 1, 2, 3. No, I said it was going to be... Oh, it's almost... How did that work out? That's almost 20. I have to figure out what went on there. That's very strange. Okay, so this is 5. Let's make sure this is accurate. Yeah, 5. Okay, 5 nautical miles from here. Okay, 1. So 10. And then 15. Okay, it's a little bit less. 15. So almost 20. Yeah, 19. I got 19 nautical miles. Okay, so Part D, they said it was 19.7, and I said it was 19 nautical miles. Okay, well, agree to disagree, I guess. Okay, now let's go to the last part. And so the magnetic heading to stay on course, I said was 260. They said it was 258. I said the boat speed was 5 knots. They said it was 5.1. And my estimated time was 15:28. And they said it was 15:36. Okay, so at the end of these problems, you can kind of see how the errors that are going on throughout the problem compound. That just by being off 1 degree, that starts a whole chain of events where your numbers may be a little bit off. So, try to make your pencil mark smaller. I think maybe in reflecting on this, some of my pencil marks were kind of big, like that pencil mark right there is a bit big blob. There might be some error associated here with my estimation for where the set line is, drift line. So I guess in summary, I would say that just be careful on a map when the distances are especially large, because your errors will add up. Even when you're trying to be as careful as I was, you can see how that occurred throughout the problem. Overall, I'm pretty happy with everything. It just at the end here, this part kind of screwed me up a little bit, and that's the way it goes. All right, well, hopefully this helped you with your navigation and gives you an idea of how to do one of the more complicated problems, which is that type 2 set and drift problem, or what they say is situation 2 current triangle. All right, good luck everybody.